Good everyone. Here is a question. A mentor of mine gave me to attempt. The question goes thus: a 3-year-old child is being diagnosed of genitourinary sepsis. The healthcare worker decides to give 𝗗𝗔𝗟𝗖𝗨𝗟𝗔𝗧𝗜𝗢𝗡 at a dose of 3 mg per kg in 3 divided doses. Calculate the estimated dosage to be given. Now, this question, once we are given any question, we have to sit, read, and understand the question carefully. Now, as per this question is concerned, for anyone that knows the right thing to do, you have to know that something is missing in this question. We are given the age of the child, the stock, that is the medication to be administered, and their dose. But for us to calculate the dosage, we have to know the weight of the child. So in order to calculate the weight of the child, there is a formula proposed for that, which is 2n plus 8, to calculate the weight of the child between 1 to 6 years. Here's the formula: 2n plus 8. So the n is said to be the age of the child. Age of the child in years. So n is the age of the child in years. So when we substitute, we have the child is 3 years. 2 times 3 plus 8. 2 times 3, that's 6 plus 8. So we have 14. So the child is 14 years. A 3-year-old child is said to be 14 kg. So now, our standard prescription, as far as this question is concerned, is 3 mg per kg per day. This is the standard prescription, 3 mg per kg per day. So now, since we have the weight of the child to be 14, so for our required strength, that is the dosage we have to administer to the child, in order to calculate that, so we have the weight of the child, which is 14 kg times 3 mg per kg. So kg cancel kg, so 14 times 3, we have 42 mg. So the child is expected to receive 42 mg of gentamicin per day. The child is said to receive 42 mg of gentamicin per day. Since we have our required strength to be 42 mg, so we don't know the mean. So the required strength equal to 42 mg per. Since we don't know our mean, we assume our mean to be x. So we assume our mean to be x, and our stock strength, that is the actual dosage of gentamicin, is 80 mg per 2 ml. So our stock strength is 80 mg per 2 ml. So now we are looking for our required strength in mil. We have gotten the milligram, so we are to calculate for the mil now. So we say required strength in mil. So that's what we are looking for now. So we say our required strength in mil is equal to our required strength in milligram times our stock strength in mil over stock strength in milligram. So now our required strength in mil is what we assume to be x mil. So that's what we are looking for. So our required strength in milligram is 42 times our stock strength in mil. We said our stock strength is 80 mg per 2 ml. So our stock strength in mil is 2 divided by stock strength in milligram 80. So we say 42 times 2, that's 84 divided by 80. So that's it. So if we say 84 divided by 80, we have 1.05. So therefore our x is equal to, so we can approximate that to 1 mil. Approximately 1 mil. So if we say the child is receiving 42 mg per 1 ml per 15 kg per 14 kg rather per 14 kg per day. So this is the standard prescription for the child. 42 milligram per 1 ml. That is, the 42 milligram will be measured approximately 1 ml. We approximate it to 1 ml. So per 14 kilogram per day. So now we are expected to calculate it in 3 divided doses. Since we are getting a value for day, so we now divide this day into 3. As we have 24 hours in a day, 24 hours in a day, so we divide it into 3 as 8 hours. So now we are going to calculate the injection the child will receive. 42 milligram per 1 ml is for 24 hours. So to get our 8 hours, so it's divided by 3. So now we divide this by 3 also. That is 42 milligram divided by 3, 1 ml divided by 3. So 3 here 1, 3 here 14. And we have 3 in 3 1, 3 in 1 have 0.3333. So we have 14 milligram per 0.3 ml. So the child will be receiving 42 milligram of gentamicin per day. But if you have to calculate it in 3 divided doses, that is 8 hourly, 8 hourly, 8 hourly, the child is going to receive 14 milligram, which is equivalent to 0.3 ml of gentamicin for the first 8 hours. 14 milligram, that is 0.3 ml for the next 8 hours, and another 14 milligram for the next 8 hours, which makes up 24 hours. So that is simply the solution to this question. So thank you for watching. I remain 𝗗𝗥𝗨𝗟𝗓𝗓. Bye for now. I see you in the next video.